In section 3, we're going to talk about calculators and approximate numbers. Now, this we're going to have to kind of take our time with because we really got to understand what's happening. All right? So, to help us, why not just use a calculator? All right? So, I'm going to go ahead and pull out my calculator real fast. So, here it is. I'm going to turn it on. If it'll turn on for me, there we go. And let's also get this LCD screen up. There we go. All right. That way you can kind of see it and everything, what I type. Now, first and foremost, this calculator is only as good as the approximations it gives. So what does that even mean? Well, let me show you. If I wanted to multiply, let's say the number 65 times 3.14, all right? I get this beautiful number here, which is 204.1, all right? And that is just a straight up exact number. That's exactly what it is, okay? But watch how this changes, all right? Same exact thing, 65 times, except this time, I'm going to multiply times pi, which 3.14 is an approximation to pi, okay? But if I use the actual number pi, here's what we get. We get 204.2035225, and that's all the calculator shows us. So give me a second. What I want to do is I just want to take this, and I want to copy this down into our notes, because I need to explain some stuff here. All right? First and foremost, all right, this number, 204.2035225, is an approximation. All right? And what makes this an approximation is that number right there. The calculator rounded this number. So in other words, what I'm really trying to say here is this. This could have been 204.20352249, and what the calculator did is said, well, I don't have enough space on my screen, so I'm going to take this place value, I'm going to look to the right, and I'm going to round it. And it rounded it up to that 5. Or this could have been something like 204.20352253, and the calculator said, I'm running out of space on my screen, so I'm going to round this 5 and look to the right, saw it was a 3, and then kept it the same. So this last number, this 5, is uncertain. And that's what we mean by approximate numbers and then exact numbers. Here's another example. This one is easy. I can write this one down. 1/3 is an exact number. Okay? 0.33333 repeating, because that's what 1/3 is. I mean, if we got our calculator out again, all right, and we hit 1 divided by 3. Notice it says 0.333, just keeps repeating forever and ever and ever. This is an approximate answer. Okay, because this 3 at the very end just keeps repeating. Same thing with 2/3. Beautiful number, 2/3, exact. However, if you take out your calculator and you type this, notice it rounds that very last number. 0.6666, a bunch of sixes, and then it has a 7. And that is because the calculator is physically out of space. Okay? So there's our idea between approximate numbers and exact numbers. Okay? So 0.66667. This is an approximate. So when you're doing homework and stuff like that, if the question says give an exact, so like in your homework, if the question says exact answers only, what they're telling you is no decimals. So if your answer is a fraction, leave it as a fraction. If your answer is 65 pi, leave it as 65 pi. Do not multiply them out. Now, the next thing we're going to talk about, and this is always the biggie, if you've ever taken a physics, chemistry class, it's this thing called significant digits. Okay? And it's not as bad as what you think. I'm going to give you some examples here to kind of figure it out. All right? So the first, 42.7. There are 3 significant digits here. So we'll call them sig figs. Okay? Significant digits. All right? Now, what makes them significant is the fact that every single one of these numbers is important for us. So the 4, the 2, and the 7, all important. We cannot do this, or we couldn't do any calculations without these 3 numbers. Okay? Now, the next number, 0.041. It has 2 significant digits. And I'm going to write this out because this is important. All right? Now, the reason why we have 2 significant digits here is because technically that 0 is not needed at all. And what I mean by that is if we were to take this number and convert it into scientific notation, so moving this decimal 2 places to the right, notice we would write it as 4.1 times 10 to the negative 2. And you can see there's only 2 numbers here. So that is why this only has 2 significant digits, the 4 and the 1. All right? So what we can say is if a 0 is used to place a decimal, all right? And I'm going to write this in red. So this is the 0 I am talking about. So if the 0 is used to place a decimal, it is not significant. And that's because we can write this in scientific notation. All right? Now, over here, with this example, let's say 1400. Once again, these 2 zeros are used to place a decimal. The decimal on this number is on the far right. So, how many significant digits? 2 significant digits. Again, we could write this number as 1, 2, 3, 1.4 times 10 to the third. Okay? Once again, 2 significant digits. So, if the number is used, or I'm sorry, if a 0 is used to place a decimal, it's not significant. Then there is this example here. $302. This has 3 significant digits. Okay, we have 3 significant digits here. And that's because this 0 in the middle is not being used as a place value. It's not being used, like to shift a decimal. Like, we need that number. This is 302. So if a 0 appears between 2 non-zeros, it is significant. Okay? So 302, 3 significant digits. You need all 3 of these numbers to get the actual value. Okay? And finally, we have this example. Now, take a minute, pause the video, think about how many significant digits there are, unpause, welcome back. I'm going to tell you how many there are here. In this example, we have 1, 2, 3, 4, 5, 6 significant digits. All right, and I'm going to underline them. 1, 2, 3, 4, 5, 6. The last 0 is not needed. So we have 6 significant digits in this example here. Okay? These 3 zeros in the middle, 1, 2, those zeros all appear in between non-zero values. We need them. This last 0, if you really think about it, that 0 can go on forever and ever and ever. So we don't need that value there. Okay? So I tried to, I don't know, maybe trick you, but, I think you're smart, and I think you can get this. In fact, I know you're smart, so don't worry about it. The last thing I want to talk about here are going to be operations with all this stuff, okay? But before we do that, we have to identify some definitions. First, we're going to talk about accuracy. All right, accuracy refers to the number of significant digits a measurement has. All right. Precision refers to the decimal position of the last significant digit. Okay? Now, these two definitions are important because what do we do with operations on these numbers? Because remember, you're going to be measuring all different types of things, right? So for example, let's say you measured, all right, a table. This is a table. Okay? Now, you measured the width or the length to be 24.5 inches. You measured the width to be 10 inches. Okay? Now, if you wanted to find the area, let me zoom out here a little bit. If you wanted to find the area of the table, all right, we know area is length times width, correct? So here's the issue. The 24.5, that 0.5 is basically a guess. It could have been 24.49, could have been 25 or 24.54, all right? So this right here is our issue, all right? Also, you're telling me the width is exactly 10 inches, like perfectly 10? There's nothing else there? So what's happening here, all right, is when we do these operations with measurements, we're going to have some sort of tolerance or some sort of error, okay? So here are the rules for this. Now, I took this directly from our book. Let me see if it'll let me do this here. I think I lost it, to be honest with you. Oh, there it is. Perfect. So go ahead, pause the video and write these down, and then unpause it, and we're going to talk about them. All right? So When approximate numbers are added or subtracted, the result is expressed with the precision of the least precise number. When approximate numbers are multiplied or divided, the result is expressed with the accuracy of the least accurate number. Okay? When the root of an approximate number is found, the result is expressed with the accuracy of the number. And when approximate numbers and exact numbers are involved, all right? So something like pi plus 1/3. The accuracy of the result is limited only by the approximate numbers, because that exact number is exact. We know exactly what that is. So I think it's better if we just look at some examples here, okay? So here are two numbers. We have 34.81 and 19.7. Find their sum. Okay? So the first thing is, we know from back in the day, whenever we add decimal numbers, we align the place values and then we add straight down. Okay? So 115, carry the 1. It's going to be 9 plus 4 is 13, plus 1 more is 14. Carry the 1. 3 and 1 is 4, plus 1 more is 5. So back in the day, mathematically, it's 54.51. However, since these are measurements, and 19.7 is our least precise number, then according to option 1, when approximate numbers are added or subtracted, the result is expressed with the precision of the least precise. Our answer is only 54.5. Okay? That's it. All right? Now, what about multiplying or dividing? So let's go ahead and let's multiply 2.3815 and 20.7. Okay? So I am not going to get crazy with this. I'm just going to go ahead and use my calculator. Oh, need my notes back. Here we go. Like I said, I took the table out of your book, so I just went to the book. If anybody wants to know how I copy and paste things into our notes, just send me an email and I'll show you how I do it. So we got 2.3815 times 20.7. All right, so here's our result. Actually, I don't like that. I'm going to use the calculator one. All right, so here's the result, all right? Now, when we're multiplying or dividing, we need to look at, and let me go back up to the notes, we need to be expressed as the accuracy of the least accurate number. What does accurate mean? Refers to the significant digits of the measurement. So, 2.3185, well, that has 1, 2, 3, 4, 5 sig figs. 20.7 has 3. So even though we came up with 49.29705, we are only allowed 3 significant digits. So our answer is 49.3. Okay? So I hope this is helping. All right? And that is going to be it for this video. So I'll see you in the next one.